Hi guys, today now we're going to discuss a multi-story design and analysis of a multi-story building using ETAP. This is a project-based assignment which is done by seeing the online tutorials of Skyfi Labs on ETAP. Today we are going to see the multi-story building of a 10-story building having the beams and columns of size 350 by 350 and having a slab of thickness of 150 and also with the dead load and live load and wind load and seismic load. Today we're going to see first we need to design the model. For designing the model, first in the E-tab, open the E-tab and open the new model. When you open the new model, you will get a pop-up and make sure the settings are made according to this. Display units are in SA system and the steel section database of India and codes of IS 800 and AS 456. Click OK. And then now use the X direction grid lines. Their default values are there in the system itself. So if you want to change the number of lines or number of spacing of the grid system, you can change. Let us make this as a 5 lines and 4 lines in y direction and make a spacing of 4 meters and 4 meters. If you want to customize the grid spacing, you can do by this option. And also the story data. We want a high-rise building, so we want at least 10 stories with each story height of 4 meters height and bottom story height as 3 meters. It's okay. Then select the grid only, click OK. Then you can see model of our structure as we presented this. This is just a line diagram with no materials and no dimensions are assigned. So now first of all we need to add material, define material. So to define materials, click on define material properties. Now we need to add materials. What materials? Grade of the concrete and the grade of the steel which we are going to use as reinforcement of the concrete. So add new material, region as India, material type as concrete, India and grade. We will take N30 grade of concrete. Click OK. You will see the default values above here, so that if you want to change any values of these, you can change or else keep this as it is. Now add another new material for which the rebar. Change the material type as to rebar and India and take HYSD grade 415. Click OK. You will be having the same default values. Keep it as it is and click OK. And then add another new material of mild steel for ties and shear reinforcement. So click mild steel 250. Rebar India. Click OK. Don't change the default values. Click OK. These three are the new materials we assign. Click OK. And then now we need to draw some section properties. So for drawing some sectional properties, we need to define those sectional properties. So define sectional properties, frame sections. So we are going to add beams, columns and slabs and also the walls. If you want walls or else auto cladding, you can do it by ladder. Now add new property. You can change here concrete rectangular or else directly you can click on here. And now give the name of this column. I am giving column C as C and 350 by 350. Change the material as M30. Change the depth as 350 and width as 350. And also change the reinforcement, modify. So that for a column, the check mark should be on this position and the longitudinal bars is of HYSD 415 and mile 250 as tie bars. Keep the cover 40 as it is because the columns have the default value of cover 40. Click OK and OK. And also click on the column 350 by 350 just now created and add copy of property. So that for easy purpose we can add beam of 350 by 350. Or else we can change any other name as we wish. Take M30 on the drop down and depth and width are of 350 and 350 as we done the copy of the property and modify the rebars. Check M3 design only because beams should be designed for only moment of M3 only. These are for beams and longitudinal bars is HYSD 415 and ties Now we defined frame section properties. Now also we need to define slab section properties. So section properties, slab sections. In the slab section, add new property. Give the naming of the slab you need to add. I am adding slab of 150 mm thickness. So make slab material as M30 grade and change the thickness of 150. Click OK. Click OK. Then slab section property is also defined. Now go to first floor by navigating through the move up and move down arrows. You are in first story. Now we need to draw the beams and columns. First let us draw columns. So for columns draw beam for columns for brace objects. Quick draw columns. Change the property as column 350 by 350. Now drag all the grid elements in the model so that at the corners we will be having columns. This is done only in one story. We need to add this to every story, so that make sure that you are drop down all story option from here, right side corner, and then drag every column. Every story is assigned with a column. Now draw beam or column. Quick draw beam or column. Now take the property of beam so that we can draw the beam. Now drag every element in the model plan view. Then every beam is drawn. Click. After adding beams and columns and after clicking escape, now draw the slab section. To draw the slab section, click on draw floors or wall objects. Quick draw floor or wall. Select the property as slab 150, which we have predefined, and then make sure that it is all stories are selected. Now drag the model so that you can see every floor, every story is assigned with the slab. Now we need to add the cladding. So to add the cladding, click on auto draw cladding, so that the claddings will be drawn at individual floors with respect to the floors. If you want to draw the claddings with only some part, so that you can use the selected those beams and draw the claddings to those parts. Now click OK. So now you can see that cladding is added everywhere. And now we need to assign the loads. Before assigning the loads, we need to make sure that the base is of a fixed base. So that to give that as a fixed base, go to base, plan view, z equals 0. In that place, we have the slab floors, which is already assigned due to selection of all stories. Now select the individual stories. Delete this one, click escape, and now select every panel. So every panel is selected. Make sure that 132 should not select 132. We should select only the base floor panels, so that make sure that you select only one story, and now select these values so that you will be selecting 12 shells. So the 12 shells we have selected, and now click delete so that all the shells are deleted in the base. Now we need to assign fixed support to this joint, to this base. So to assign that thing, drag the cursor, select all the points. Now assign joint restraints, click on fix, apply, OK. So that every joint is now base of the base joint is of fixed support. Now we need to add dead load, live load, wind load, and seismic load. So to add dead load, live load, wind load, and seismic load, make sure you go up. Now make sure that you select all stories, and now define load patterns. So by default, you will be having load patterns of dead load, live load only. So now, if you want to add an extra load of wind load, you need to type here wind. Take the wind load from the drop down wind, and now auto lateral load is of from code Indian code of IS 875 1987 is the code. Select the code, add new load, and if you want to and you need to modify this wind load, we will be discussing that later. Now click OK. Now we need to add the dead load. To add the dead load, now first you select the shells, so that you select all stories and every shell need to be selected. Make sure 120 shells are selected. Now after selecting the shells, now assign the load. Go to assign shell loads, uniform loads. We are assigning dead load of 2 kN per meter square to every shell. It is in gravity. Replace existing load. Apply and OK. So that every shell got selected and every shell is assigned with a dead load of 2 kN per meter square. Now the same thing you need to assign live load. So select every shell again, or else you can use the select previous selection, so that all the cells which we previously selected get also selected. That will be, I will show some other time. So 120 shells are selected. So after selecting the shells again, assign shell loads, uniform loads, change the load pattern as live load, take live load as 3 kN per meter square. Let us assume. Apply. OK. Now you can see every shell is acting live load and dead load of 2 and 3 and 2 respectively. But now you can see that when we go for a top floor is also assigned with the live load of 3 kN per meter square. But we don't require the top floor with 3 kN per meter square. So we will change the live load of top floor as 1.5 kN per 2 kN per meter square. So to make sure that select only one story. Now select the story. After selecting, 12 shells are selected. Then assign shell loads, uniform, live. Now change it to 2 kN per meter square. Replace with existing loads. Apply. OK. So that the top floor is of assigned with the 2 kN per meter square of this live load. And now we need to assign wind load. To assign the wind load, now we need to go refer after assigning the loads. Now we need go to define load patterns, wind load, modify the lateral load. See, now in this modification, you need to give the wind characteristics or wind parameters as per the IS 875 part 3, which is our wind load code. So wind speed in IS 875 part 3, we will be having different wind speeds for different specific regions. So let us assume this is in a Bangalore city. So for Bangalore city, the wind speed will be of 33, and the terrain category, generally we will be having 3 terrain categories that will be based upon the IS 875 part 3. These categories will be based upon the obstructions near the constructing the obstructions near the structure. So that check in the code and see whether in which category the building is going to fall, in category 3 or category 2 or category 1, based upon 6 6.3.2.1, and then define the structure class. If the building is of more than 50 meters, then we will be in class C. If it is 20 to 50, class B. If below 20, class A. As our structure is of a 10-story building and each story is of a 4 meters height and 40 meters and base is of 3 meters, 43. So it is a below 50, it will be in class B. And topography factor is 1 and this coefficient factor is 1. Take that from IS 875 part 3. If you want, I will be discussing about the IS 875 part 3 in some separate video. Now click OK and also click OK. And now we need to add wind loading. So to add the wind loading, go to elevation view of section A. Okay. And in this section A elevation view, now make sure that you turned on all stories from right bottom and select the shells of every shell in the section A. Now click on assign shell loads, wind pressure coefficient. So this wind pressure coefficient we will be having from IS 875 part 3. So in IS 875 part 3, from table 5, we have height divided by width ratio. Based upon the height divided by the width ratio, we will be having some coefficient. As we have a height of 43 meters and of a width is of, we have a width of 3 spans of 4 meters, means 12 meters. So 12 meters width and 43 meters height. So approx 3 point something, which is between 3 by 2 to 6. And from 3 by 2 to 6, we will be having length by width ratio. So length is of 4 spans of 4 meters, 16 meters. So 16 meters of length and width is of 12. 16 by 12 is 1.33. 1.33 is between 1 and 1.5. So from this, we will be having at a theta equal to 0 degrees, we will be having the coefficients of plus 0.8 in A direction and minus 0.25 and minus 0.8 and minus 0.8 in remaining directions. So to change from 2, we need to enter these values in our model. So coefficient of plus 0.8 plus 0.8 in windward direction. Apply. OK. And now select in elevation view, select section D, apply and OK. Sorry, we need to select the elevation view on one tab where we have selected the previously. Now we need to select the elevation of last elevation so that the wind will be facing on the last face. This is the elevation E. So make sure that all stories are selected. Select every story. Shell. Now assign the load. Assign shell load wind pressure coefficient, which we already got, minus 2.5 in leeward direction. Click leeward, minus 0.25. Apply. OK. Now go in a plan view of any one story. Click OK. Now we have added windward direction and leeward direction. We need to add for sidewards. For that we need to have sections of 1 and 4. So go to elevation of 1. OK. And now click every shell so that we need to select it. And now we need to add assign shell loads wind pressure coefficient, and for the wind pressure coefficient we have minus 0.8 and minus 0.8, leeward direction or sideward constant. Okay. And also we need to select go for plan view of any story. We need to select the section 4. So select elevation 4. Okay. Now select every story shells. Now assign shell loads wind pressure coefficient minus 0.8 leeward. Okay. So every direction is assigned with the wind load. If you want to see in any. So now here we can see the direction and the coefficients of each wind load in each direction. So we got every wind load also. Now we need to analyze our beam, analyze our building. So to analyze, go to analysis. Before analysis, we need to have load combinations. So for that, define load combinations. Go to load combination. If there are no load combinations, add default load combinations. Select concrete frame design. Click OK. So that we will be getting some load combinations based upon the wind, live load, and dead load. Click after selecting the load combination. After selecting the load combination, now we need to analyze. Go to analysis, set load cases to run. For the time purpose, let us resume the analysis of modal load case. So click on run or do not run case so that the modal analysis will not be run. So let us run for dead load, live load, and wind load. And now click run now. And you can see the bottom left corner the progress of the analysis. In 3D view, you can see the deformations of every story because of it was deformed. It made that displacements will be shown after analysis. So if you want any moments and all other things of that frame section, go for display, diagram, frame, and if you want a moment in 3 direction, click on apply. You can see moment. If every point you can have the value in left bottom. Just close this tab. Right click on the beam. You will be having the equivalent load, shear, moment, and deflection of that beam with respect to the loads we assigned due to the analysis. Now close it so that you can analyze each and every beam. And now we need to design the building. So for design, go for design, concrete frame design, view revise preference. In here we need to make sure that IS456 is selected. Click OK. And again design, concrete frame design. Click on start design or /check. Wait for the model to get designed. Now design is over. So that now you can see the values, design values or the reinforcement values as shown in the model 1025 for this column as a reinforcement bar. And here the top end reinforcement is of 272 and bottom end reinforcement of 360 and middle top is 68, middle bottom is 360 and so on. So that you can have the detailing and reinforcement bars of each and every column and beam. And if we want to check that all the elements or frame structures in this model satisfying the design or not, so to that go for design, concrete frame design, and click on verify all members pass. All concrete frame photo pass. All concrete frames pass the design check. This shows that our design values of the loads we assigned, and then click OK. And if you want to add the seismic loads, make sure that you need to unlock the model, because after analysis your model will be logged. So you need to unlock the model and then go to define load patterns. As my version is of E-type evaluation version, we cannot add more load pattern. So first delete the wind load pattern. If you are having the original version, you can add the number of load patterns as you want. Now add seismic load. Select the type of load as seismic or drift. Seismic. Now auto lateral load. Sorry, there is a small problem. Uh, let us select the auto load from here. IS 1893 2000. Select IS 1893 2002. Add new load and modify the lateral load. Modify the lateral load. In seismic load, we will be having IS 1893 code. From that code, we need to first have seismic zone factor. So seismic zone factor depends upon the location of the building. So if our location is in Bangalore, and it comes under zone 2, and for zone 2 our zone factor will be of 0.1, and site type, and our site type, let us assume our site as medium rock. So for medium rock it will be of type 2. An importance factor of our building, for 50 years construction period of estimation, importance factor is of 1. So select 1. Response reduction factor, and response reduction factor was also took from IS 1893. For detailed detailing we will be having 5, and for normal detailing we will be having 3 as a response reduction factor. So I am having 3, and click on OK, and click OK. So for seismic, we no need to assign the seismic load on building, and for now for the seismic load, we need to define some functions, some seismic functions, whether we need to assign that in a response spectrum function or time history analysis. For that, we need to define the functions. Here we have defined functions, response spectrum function. In response spectrum function, choose the Indian code of 1893 2016. We are having, and add new function. Let's give the function name as seismic. No, response. And now seismic zone. As we know that our zone is a zone 2. It automatically took 0.1. Importance factor is 1, and soil type is 2, and response reduction factor is 3. You can see that by changing every value, we are getting change the graph value, so that the response reduction factor will be changing. By changing the response spectrum, by having this response spectrum function, we will be having our maximum response of the building for a given particular period or time, or frequency of the natural frequency of the building, so that we can analyze the building response for a given mode of vibration. Make sure that the damping ratio is of 5%, 0.05. For concrete buildings it will be 5%, and for steel buildings it will be 2%. And then click OK, and then click OK. For giving seismic load pattern, we need to assign the load case. Go define load case seismic, modify the load case, and the load case type is response spectrum, and we need to add the response spectrum, so that acceleration is of load type, and load name is of u1, and function we need to add response as a function, and scale factor. This scale factor means for calculating response reduction factor, scale factor, we will be having a formula of calculating acceleration in code IS 1893 2016. In IS 1893 2016, we will be having an acceleration formula as A is equal to Z by 2 into SA by G by divided by R by I. By having, instead of taking this zone factor, as we already give the zone factor, SA response reduction factor, and G, R and I importance factor also will be giving later. So instead of Z and I, SA by G by 2R, the value of SA by 2GR is 1633.5. If you calculate, you will be getting 1633.5. Then add another one for that, for another direction. Take response and have the value of 1633.5 and set the direction combination value as CQ C3 and then click OK and click OK. Now analyze the structure. Set load cases to analyze. Make sure that every modal load case, seismic load, dead load and live load, everything is getting analyzed and run now. Wait for the model to get analyzed. It will take some time because we have 10-story building. Now the analysis is got completed. If you want to see the animation, we can see the animation. On the right bottom, we have start animation. Animation, and you can stop the animation also. Now we need to design this for the given seismic load. So design, concrete frame design, use the revised preference IS 456, click OK, and again design, concrete frame design, start design or check. Wait till the building get design. Building or design, and we need to check that every member is satisfied or not. Go for design, concrete frame design, verify all members pass. All concrete frames passed the design check, so that now our building is analyzed for wind load and also seismic load, and we got every member was got passed from the check. So here we can, this is where we analyze the building in ETAP